by popular request, I'm going to take a closer look at this Anyang socket detector. They call it a socket detector phase meter, but it doesn't really meter phases, though it does meter the voltage on the outlet that you're plugged into. But its main job is to identify if your outlet is wired correctly, and as a bonus, we'll test GFIs to make sure that you're in compliance there. Now, we looked at this a little bit during the mailbag, so I'm not going to go too in-depth into how it operates, and I think we've seen these kind of things before anyway. They're available in EU versions or the North American version, which is of course what I got because that's where I am. When you plug it in, the first and most obvious thing is the voltage, 121 volts AC, which is correct enough. This is odd. In real life, I can see that the PE, protective earth, and the L, live LEDs are lit, and the neutral one is not, which is the indication for a correctly wired socket. You on the camera, for reasons that I can't quite explain, can only see one of those LEDs at a time. And yeah, you can see it just kind of cross-fading there. That's not happening in real life. That is just an artifact of the camera. And just to demonstrate, if I plug my power bar into an incorrectly wired outlet, please don't do this, I'm just doing this for demonstration, but I've got my hot and neutral reversed, as you can see here. Then it looks like that. Oh, you can see the neutral and protective earth, aka ground, lit. Okay, so that tells us that I've got a line and neutral reversed, or live and neutral reversed, which is exactly what I've got. Huh, why can't you see those now? Another weird camera artifact. Those two are both lit now, as they were before. I am not sure why that is. I'm assuming that there's some multiplexing going on inside here in the display, but that is something else that we will try and discover through our little exploration here. Now, I think that there are screw holes underneath this label, and I hope I don't completely destroy the label by removing it, but I'm going to do my best here. Yeah, there's a couple of screw holes, but only two. There's one up in this top corner here, and another one down there. So let's see what is revealed by peeling those apart. That top comes off easily. Okay. Revealing that we have a red wire on the live, a black wire on the neutral, and is that gray or dark green on the ground? That's reasonable enough. And it looks like those can be, or that plug piece can be popped out somehow, which is how they would replace it with the European one for the EU version. Down here on the board, that appears to be the 7-segment LED on the other side. We'll look at that in a second. We have a couple of electrolytic capacitors. That one is a 16 volt 100 microfarad, and so is that one. And this capacitor is a 474, that's what, 470 nanofarad, 450 volts. So I'm guessing that's going to be probably a capacitive dropper for the voltmeter circuit. How does the circuit board come out? Is it just clipped in there or something? Oh no, there's one screw that I somehow didn't notice in the corner. Okay, get that guy out. And what do we got on this side? Oh, surface mount stuff. Yay, my favorite. So on this side of the board, we have the push button for testing GFI. You got a smattering of resistors. We have 1, 2, 3, 4, 5 large diodes, one smaller one. There's the 3 LEDs up there. A 3-pin transistor-like device, which may or may not be a voltage regulator. And the main chip, which has absolutely no markings on it, you bastards. But the large diodes are all marked M7. The small one is marked WH. And this 3-pin device is a 7550-1. Let's go look that one up. As expected, it is a low voltage dropout regulator, specifically a 5-volt one. And not much else to see. There it is there in the SOT to 89 package as we have on the board. So yeah, nothing too fancy, just a low current 5-volt regulator. It will be providing all the voltage that the microcontroller or whatever that chip needs, and everything you need to light up the 7-segment LEDs. That's all it's doing. So those M7 diodes appear to be nothing more than a standard rectifier diode. The M7 is a 1 in 4007 equivalent, which means it's got 1000 volt peak reverse voltage. Yeah, just a standard silicon diode. Nothing weird going on there, as expected. And that WH diode is a Zener, specifically a 12 volt Zener diode. So that's also power supply stuff by the looks of it. All right, I've spent a bit of time and have come up with an ugly looking schematic, but I'm pretty sure it is correct. So there's basically three things going on in here. There's the voltmeter, there is the LEDs that are telling you if your socket's wired correctly, and there is the GFI tester. We'll start with the GFI tester because it is the most simple. It is a switch connected through a 6.8K resistor to the live and another 6.8K resistor to the ground. If you push that switch, it puts 13.6K across the live and ground, which works out to 8.8 milliamps, which should be enough to trip the GFI, especially since this thing says that it's only putting 6 milliamps across it, but it claims to be doing that at 250 volts. I assume for 250 volts they would actually put different resistors in here in these two positions to get to that between 6 and 8 milliamps. Regardless, that's enough to trip a GFI. I know it is because I tried it. So the LEDs, we'll start with the first one, comes from the neutral through one of the rectifier diodes, through 100K resistor, the LED, and a second 100K resistor, and then off to the ground. So that one will only light up when the neutral is actually hot, when you've got a live neutral reversal, because normally neutral and ground are the same potential. So that one tells you that there's something wrong. The second one, again, from the neutral through the rectifier diode, 100K, another LED, another 100K, and that goes off to the live. That indicates that the live is correct. And the third one, the PE, this is how it's labeled on the device, exactly the same, except for it comes from the live, through the rectifier diode, through the resistor, LED resistor, and goes back to the ground. So under normal circumstances, the live and the PE will be lit and the neutral one will be not lit. Anyway, the other rectifier diodes, there's two of them there, and they are forming sort of a half-bridge rectifier kind of thing. Then we have the Zener diode after this one. It has a capacitor across that. What are those capacitors? Again, 100 microfarads, 16 volts, which makes sense because it's only a 12 volt Zener, and that's fine. Anyway, out of that Zener, or after that Zener, goes to the common 0 volts. Let's not call it ground because we got ground over there. Yes, I know it's written there as ground because that is what the 3-pin 7550 regulator calls it on it. Its input comes from the other side of the Zener, and this ground comes from the circuit 0 voltage. The output of that guy, 5 volts, into the capacitor, and to the 5 volt input of the 16-pin chip of mystery. And its 0 volt, of course, goes to the DC 0 volt inside here, which is also referenced directly to the neutral. So that's how it sees the neutral as well, because on pin 14, through a couple of 200K resistors, and how do you draw a 0 ohm resistor, guys? I just drew it as a resistor with a 0, I don't know. It's really just a piece of wire, but regardless, it's a 0 ohm resistor on the board, so that's how I drew it as. And that goes to the live. So that's how the live and neutral gets sensed by this guy, which will be doing voltmeter things, and talks out to the 7-segment display here. I couldn't get a good count on how many pins that actually is. It's multiplexed, so it's not going to be a large number of pins, but because they all disappear underneath here and through vias and stuff, and I can't see them, we'll just draw it like that, right? Right. It's a neat little circuit, makes perfect sense, nice and modular. Even without the voltmeter in here, we wouldn't have, this whole chunk here, and probably not that. It would just be that. And that would be a fairly easy thing to make if you wanted to, although I wouldn't recommend messing around directly with mains voltage unless you really know what you're doing. But it's pretty straightforward, and that will be what's in the majority of the really simple, cheap ones that you can get too. Well, I think I am going to put this back together off camera because that will just be the reverse of how it came apart. It's a fairly solid little thing. The circuit inside is no more complex than it needs to be. There are a couple of positions for other components. Some sort of a little 3-terminal jobby there. This is where the voltage sense happens. There's the live, there's those resistors in series, and then it ducts underneath here through a couple of vias and over to the chip. So I'm guessing for the 250 volt version, that 0 ohm link might come out and something else might go in there, though I'm not quite sure what that is. That optional 3-pin device is behind a hole in the case here, so maybe it's an LED or some other indicator. I am not sure. And then from the live over here, there is another optional component that could go in here. Again, don't know what that is. This pair of pins here is the dropper capacitor on the back, so perhaps that's just an optional surface mount version of that big honking capacitor on the back of there. Don't know, but that is about all that I've been able to figure out about the thing, which is more than enough for me. Well, thanks for coming along with me to satisfy my curiosity. There was one suggestion in the comments from the mailbag video where this thing showed up that Anying makes another version of this that looks surprisingly similar that works with a circuit tracer. This one clearly isn't that. I'm 99% sure that's not what's going on inside this one. I think that would be an additional piece of circuitry. But it was interesting finding out anyway. Well, if you've got any questions or comments, obviously put them down below. I'd love to hear from you. Have you taken apart any other variants on this theme? I do have another one that I showed you in previous videos. It doesn't have the voltmeter on it, but unfortunately it is glued together. It doesn't have screws on it. I can't find a way to get it apart without completely destroying it, so I'm going to leave it intact for now. That's about all I've got to say about you. I'm just rambling. I will go and edit and enjoy my beer. Thanks for watching. I will talk to you later. Alright, somebody's going to ask about the beer, aren't they? This was Flirting with Garth Dark Ale from Bookstore Brewing in Winnipeg.